You're welcome once more to this channel. If you're new to this channel, I'd like you to like, subscribe, and still refer to some of your friends and loved ones. If you are an old subscriber, you're welcome. I love you so much, and I would like you to refer this channel to some of your friends. Alright, without wasting much of our time, we'd like to talk about potential energy and heat energies. Alright, in our last class on potential energy, we didn't talk about the differences between kinetic energy and potential energy. But bear it in mind that kinetic energy is energy in motion, while potential energy is energy in the place. Alright, let's talk about differences between kinetic and potential energy. One of the differences, kinetic is always in motion. Is the energy of a body in motion. Now, the body of a kinetic energy is always in motion, while that of potential energy is not in motion, it's always in the place. That's one. Two, now, kinetic energy always works on a horizontal plane. The energy works on a horizontal plane, while that of potential energy works on a vertical plane. Alright, the next difference I'll give you is kinetic energy does not disobey gravity. It does not disobey gravity. But potential energy disobeys gravity. It disobeys gravity. Alright, that's three differences I can give you, and before I talk about conservation of energy. Before we move further, let us understand that there is a law of conservation of energy. Conservation of energy means a process whereby energy can be used. Usefulness. Alright, so conservation means usefulness. Usefulness of energy. Now, energy, the law of conservation of energy states that energy can neither be created nor destroyed. So you can neither create energy nor destroy it. But rather, energy can be transformed from one to another. It can be transformed from one state to another state. Let's say mechanical energy can still turn to electric energy. Your generator set is a mechanical energy. Now, when you start your generator state, now that mechanics in that engine will supply electricity to you. That means mechanical energy turning to electrical energy. Alright, your telephone earpiece is transforming the electrical energy into sound energy. Just imagine. Your microphone is transforming electrical energy into sound energy. So that is how energy can be converted. Energy convert can be stored. The solar energy can be stored to electrical energy. Okay, that is for conservation of energy. Let's talk about heat energy. Some people have this the similarity. They don't really know the difference from heat energy and temperature. The heat energy is the energy gotten from heat, while temperature is the degree of coldness and hotness of a body. Okay, temperature being the coldness and hotness of a body is measured in degrees Celsius or degree Fahrenheit or in Rankine. Degrees Celsius, Fahrenheit, or Rankine. Now, these are the degrees, but the standard for temperature is in Kelvin. The standard measurement of temperature is in Kelvin. Alright, without wasting much of our time, let us talk about the effects of energy change. The effect energy change. Now, the effects of energy change have this capacity to create increase or decrease of a body. Imagine that I have this gate in my house. Every time that the weather is hot, if I close it, I find it very difficult to close it. But if the weather is cold, if I close it, you close easily. What happens? Now, what I'm trying to insinuate is when the temperature increases, there is an increase in size of that metal. Now, when the temperature increases, there is a decrease in size of that metal. So there is also a change in heat of a body. Okay, now let's talk about things that can be used to let's see some other related examples in our day-to-day activity. You know, your bridge, when you're building a bridge, there is this little gap they always give in the bridge because of expansivity, because of the expansion of those solids. Due to the expansion, they give space due to the expansion of solids. That's why while they build it, they will give a little space so that once it expands, it will flap, it will come together. Then when it's cold, it will still go back to this original shape. Hope you are following. Alright, that is the effect of heat on change of a body. The same effect of heat can still change a solid to liquid, from a liquid to gas. That's the same effect of heat. Alright, without wasting much of our time, let's get to expansivity. We want to talk about expansivity and what it's the places where it occurs. Now, expansivity occurs in solid, in liquid, and in gas. But for today, we are going to talk about solid. We're going to talk about expansivity in solid. Now, there are three types of expansivity occurs mostly in solid. Okay, we'll talk about solid and liquid. We have linear expansivity, cubic expansivity, and area expansivity. Now, linear expansivity happens to a solid. Area expansivity happens to a solid, while cubic expansivity happens to a liquid. Now, the occurrence of linear expansivity in a solid is in length. The occurrence of cubic expansivity is in volume, and the occurrence of area expansivity is in its area. Remember, area is length times breadth. Okay, now let us define linear expansivity. Linear expansivity is the increase in length per unit increase in temperature of a body. Now, it is known with this symbol alpha. Now, we can know it by, let me say, formula says change in length all over original length times temperature rise. Now, temperature rise equals to change in temperature, which is T2 minus T1. Temperature in Kelvin. Okay, now this is for linear expansivity. Now, for cubic expansivity is the increase of volume of a body per unit of the temperature. The increase of a body per unit of a volume in the body with response to temperature. Alright, now we note it with a symbol cursive Y. Now, which will give us change in volume all over original volume times temperature rise. Mathematically, we have, temperature rise to be T2 minus T1. Alright, now we have for area expansivity is the degree, it is the increase of area per unit of the temperature of a body. Now we note it with beta, which is change in area all over original area times temperature rise. Alright, this is the formula for linear, cubic, and area expansivity. Let us go forward to some problems or to some examples which we use to explain these formulas.